Okay, great. Thank you. Uh, my name is Bhupesh, and I'm engineer at DataTorrent. Joining us on the webinar is Priyanka. She's also an engineer at DataTorrent and committer with Apache Apex. Some of the logistics of the webinar. This will be recorded and it will be available after the session is ended to watch again or share with your colleagues who might have missed it. The presentation is already available on the SlideShare. You can submit your questions throughout the session. You can submit it via the questions tab you can see on the panel, and we'll be happy to answer them as soon as they come up. Or maybe we can take them at the end of the session also. Okay, so without further ado, I'll hand it over to Priyanka. Priyanka.
Yeah, welcome everyone. Good evening. Today I'm going to talk about the ETL solution developed using DataTorrent RTS. DataTorrent RTS is actually a real-time streaming platform developed on top of our open source product, which is Apache Apex. So in this session, I'll do a very quick introduction to Apache Apex because I believe some of you are new to our webinar series and may not know about the Apache Apex platform. And to understand this solution, it's important to know what it is. So a very quick walkthrough on Apache Apex, and then we will see into the ETL solution offered by DataTorrent RTS platform. Okay. So what is the Apache? Apache Apex is actually a stream processing platform. It's developed on top of Hadoop. Here are some of the highlighting features of this platform. The first and important thing is easy operability. Using this platform, developing your applications to solve your business problems is really easy. Your coding and time to production has reduced, can be reduced a lot if you use this platform. This is possible because we have a very good open source library. If you see that second last point, we have a library called Apache Apex Mallar, and this is a library where we have open source lot many operators which can be used to develop your applications. I'll cover in brief what is an operator, but for now just remember this library offers lot many operators which are free to use, which can be used to develop your applications. That's why it's easy to operate, easy to create your applications and go to market easily. Next thing is scalability. So we have ability to scale out and scale in dynamically. It's very important when you're dealing with big data that your workload can increase or decrease with respect to time based on your events. So our platform provides you capability using which you can actually scale out if your load is very high, or scale down when you are not seeing a lot of input data. And this is all like built-in platform. You just have to configure some parameters and you should be able to use these features. Next thing is about performance. Provided that we are dealing with big data and in real time, performance is one of the critical things. So we have seen using this platform, people have achieved the performance of as good as single-digit millisecond latencies in production, which is a very, very big thing as we are dealing with very high volume of data. So performance is one of the key feature of this platform. Fault tolerance platform does take care of all the fault tolerance on its own. You don't have to code or do any thing special for that. It automatically maintains state of your application, and whenever some node failure happens, it detects it and restores your application to last known state which it has required. And the last and most important is like it is like yarn native. It uses yarn for the resource negotiation and application scheduling. This is how our technology stack looks like. So at very bottom we need a cluster. We need a so this cluster can be built using your physical machines. You can have a set of machine in your organization which you can use to develop your cluster, or you can go with virtual machines to create a cluster, or you can even go with cloud. We do support Amazon or even Microsoft Azure cloud. So you can choose any of these to create your cluster. Once you have a cluster in place, we need Hadoop on top of that. So for Hadoop, you can either go with like plain vanilla Hadoop, or you can go with any of these majority distros like Cloudera, Hortonworks, Pivotal, Mapr. We do certify on most of these famous platform, famous distributors. And one more thing, like we need Hadoop 2.2 onwards because we do use YARN for our resource scheduling. And on top of Hadoop, here comes the streaming platform, which is Apache Apex. You need this layer to run your applications. The next layer is streaming applications. These are the business solutions or applications you have developed using Apache Apex platform. They will run on our platform and indirectly on Hadoop, taking all advantages of Hadoop system. And to develop this application, as I mentioned, we have this Mallar library where you have many operators. You can just um, pick whatever you want and develop your applications based on your business use cases. And the very top layer you see is actually enterprise offering from DataTorrent. So the management console is used to monitor your applications, take certain actions, do monitoring and everything. This is also part of our community edition. So DataTorrent offers a community edition on top of Apache Apex, which is free to use for the community. Then there are a couple of other things like data visualization and graphical way to design your applications. These are part of enterprise offerings only, and still you can explain them in our free to like free trial period for I don't know, like we have some limited free trial period. You can use that. And the last thing is we also have REST APIs. So these do publish information like the application state, other application statistics, and application data. So you can connect to these REST APIs and fetch this data for your use, like using it with your UI or any other use case you have. So having said talked about platform, let's look into how our applications look like. So okay, so our application actually looks like a DAG. DAG actually stands for a directed acyclic graph. Where the nodes of a graph are equivalent to the operators. So if you remember in first slide I have talked about operators. Operators are the places where actual data processing happens, and the nodes of this and the edges of this graph are actually the streams. Streams actually carry data from one operator to another operator. In practically, these operators could be located on different machines, or they could be co-located on same machine. It depends on available resources and all. But just understand that they are working in distributed fashion, working on different machines and carrying out some processing. And the streams just help us connect multiple operators together and complete this DAG to do your processing. Does anyone have questions, or can just go ahead? Okay, I think there are no questions yet. Okay, this is how our typical application looks like. So whenever you start solving any problem, these components are typically involved. That you want to fetch your data from some outside system, so you need something to suck in your suck input from outside. We call it as input adapter. So you'll need an input adapter which will talk to different outside systems to get data. Then we have processing operators. We call them as generic operators, which will do some logical transformation on your input data. It will do some processing as per your need. And the last thing is you will want to store your results somewhere so that you can access it later for some use, for reference or some other use. So this is how a typical application looks like. But in this session, we are going to focus on ETL applications especially. And I'm just going to quickly tell you what ETL is. ETL normally stands for extract, transform, and load. So nowadays, organizations have matured a lot, and they do have their data available on different data sources. Some of them could be their traditional relational databases. Some could be the modern databases. Some could be some queuing system. So they do have data distributed across multiple, sitting across multiple sources. And what they ultimately want to do, they want to fetch all this data, they want to process it, and they want to calculate some value out of it. They want to do something out of it to use this data fruitfully. So to do all this, they need these ETL tools. They'll want to fetch that data. They'll want to do some processing on that, like they want to deduplicate data, they want to enrich the data, they want to transform and add new fields or calculate new fields based on existing information. And then finally they will like to load or store this data in some other system where they can use it for reference, they can run reports on top of that, they can run their analysis or many other things on top of that. So this is the ETL thing, and if you have attended our last session, we covered the business side of this ETL. So we did cover it is used in domains like security for data, for fraud detection, or in advertising domain, or even log analysis in IoT, like for sensor data analysis. So if you see, ETL is need of each and every business nowadays, and it is a very generic problem, and everyone is trying to do something to have a good ETL solution. So considering this, DataTorrent has come up with a good ETL solution. We do have many offerings, but I'm going to cover one of the generic ETL solutions we do offer, and we call it as Kafka ETL. I have written it as app template. The reason I will tell you why we call it as app template is we just have initial skeleton over here. We have an application which you can use as your starting point. You can actually, we have open source this a template, so you can take these templates. If it caters your need, you can directly use them. If not, you can actually use them as your template or your starting point and do modifications as per your requirement and use it freely. So these app templates are released under Apache license. I'll share your repository info and many other information in next slides. But it's actually free to use either all, and we already have already compiled applications, as well as we do release source code so that you can play with it the way you want. So the pipeline which we are going to discuss today, like ETL pipeline, looks like something like this. So we are going to read from Kafka. Kafka is like one of the major choice of people nowadays. Most of the people push their data into Kafka for various reasons, and then they start their processing pipeline from there. So in today's presentation, I'm going to consider Kafka as my input source, and I'm going to send some test data to Kafka. The data is going to be in CSV format, like a pipe separated record. That's why after Kafka, I'm using CSV parser. So from Kafka, CSV parser will fetch this data and convert these records into plain Java objects. I'm converting them into Java objects, as it is going to be easy for me to deal with Java objects than dealing with strings. So once it is converted to Java objects, I'm going to filter the records. I'm going to use some criteria. So my records are going to be bank account records where I have account number, name, and the balance in account. So let's say for my use case, I just want to process for the records whose let's say account balance is more than 10,000 rupees or 10 lakh rupees. So whatever condition is that, I'll put it here and I'll filter those records. After filtering, I want to do some transformation operations. That is, I want to transform whatever records I get, I want to change, let's say, some fields or add new fields to that based on some certain logic. And after transformation, I want to format it again in the form of CSV so that I can write it to the file and can refer it outside this application. So this is the pipeline we are going to discuss today. Okay, let's go ahead. So these app templates are hosted on our app hub. So if you actually go ahead and download our DataTorrent RTS, either the community edition or the enterprise edition, if you download that, you will see this tab over there, which is named as App Hub. So this is a repository where we actually host a lot many applications which we release as templates for your starting point or for your free usage. So please go ahead and use that. I'll show you a real App Hub on my machine. Okay. So if you can see, this is like my RTS installation, and if I go to App Hub tab, okay, this is a long list of applications DataTorrent has released, where you have many applications like HDFS Sync app, Kafka to HDFS Sync app, S3 to HDFS, dimensions them. There are many other things you can do. Today we are going to focus on Kafka to HDFS filter app. Okay, I'll just come back to it later. Going back to the presentation. Okay, let's go back to the presentation. So this is like how app hub looks like. Once you have RTS installed, you will see this link there. And for today's use case, we are going to select this filter app, Kafka to HDFS filter app. I'll go into some more details. I'll go to demo of this. I'm going to show how can you use this, how can you modify this, how can you run this, how can you configure this. All these things I'm going to cover in this demo. One thing first thing, I just show you that we have this app hub repository where you can refer to. So if you click to any app, you can see there are text instruction to use it. Also, there are recorded videos which you can just follow and use this applications templates as it is or with modifications. Also, as I said, we have open source this code. So you can go to DataTorrent repository and the repository name is app templates. Go to this repository. All these applications are code is posted over here. It is free to use. It is released under Apache license. So feel free to use it the way you want. We have this. We are going to look into this Kafka to HDFS filter application today. So let's look into this. So this code is available over here, and the compiled application is already uploaded to our app hub repository. So I'm just going to use it as it is for first time. I'm going to say import. So when I say import, it is going to download this application and add it to my repository locally. So if you go here, so it will go to develop tab and it will show this application is already there. It will also show what all applications are available in this package. Right now there is only one application which is Kafka to HDFS filter. Let's try to run this. So as you see, I have not done anything. I have not done any coding, nothing. I just said import from the app hub, and now I'm going to launch this. So when you say launch, you have to provide an application name. So this has to be unique across all the applications running in your system. Then you need to provide some configuration to run this application. So I'm going to say use configuration file. I would like to mention one more thing. The application we imported was an APA file, which is actually a package which has the code as well as other config files and any other relevant files related to an application. So we had actually packaged some pre-configured files, which are some default configurations plus all the config names which you can just modify parameters as per your needs. So there are, if you see, there are two files. One is for cluster memory configuration and another is for sandbox memory. We have put some optimized parameters based on your memory availability. Mostly cluster will have more memory and different configuration. So as I'm going to run this on cluster, I'm going to choose this. Now, obviously I have some different parameters. My Kafka is different. My file system is different. So I want to configure those parameters as well. So what I can say, I'll say specify launch properties. And now what are those properties? I don't know names. They are application specific, right? So there is an option which says add default properties. When I say this, it will fetch all the required properties and list it over here. Now let's add one by one. So file path, let's say temp and ETL demo. File name is output and output demo. Condition. Now, as I said, if you remember, I had shared. Okay, I'll go back to that slide. I had shared a DAG. This is our application DAG, and we have a filter over here. On this filter, we need to specify a condition based on which data will be filtered. So this is the condition. It says $.get amount greater or equal to 20,000. This is actually a quasi Java expression where you can actually run any you can do anything which you can do in Java. This dollar will be substituted by the object at runtime. You just have to say dollar and then whatever function you want to call it, call on top of that, and your condition. So this will be set on the filter operator. If you see that operator dt.operator.filter, its property is condition, and you set it. Next thing is cluster. So you need to provide your cluster Kafka cluster properties. By default, it's localhost. So if you are running Kafka locally, just use it. Mine is on cluster. I'll just copy my properties over here. It's as simple as this. Offset, Kafka has an option to provide initial or earliest, whatever offset you want. I'll choose earliest. And topic. Now let's create a Kafka topic for this presentation. I'll go ahead and create a topic called ETL demo. This is my machine. Okay, and okay, so this says create Kafka topic, and the replication factor is 3, partition count is 2, and topic is ETL demo. Okay, topic is created. I would like to mention one thing over here. I had mentioned in first slide that we have the capability of static as well as dynamic partitioning. So Kafka has that capability as an input operator. What do we do? Like we have the strategies, like you can either choose to have one-to-one partitioning, or you can choose to have one-to-many. What does that mean? Like if let's say here you have 2 partitions, like by default strategy is one-to-one, so that when we launch the application, 2 Kafka input operators will be created. But if we choose one-to-many, only one Kafka input operator will be created in our application for multiple Kafka input operators. Also, we have dynamic scaling capability, which means, let's say if you decide to use your partition count, we will automatically increase our Kafka input operator count based on the number of partitions you have over here. Okay, I'll just increase the font again. This is good enough. Okay. Now we have Kafka topic. Next thing I'm going to set that name over here. Our name was ETL demo. Now as you see, for Kafka we have configured topic name and the cluster names and the offset. For filter operator we have set condition, and for output operator, which is going to write to HDFS, we have specified the folder name as well as file name. Okay. Now I'll say launch with these properties. Please launch. I'm also going to show you that file which we have, config file we have used. So if you remember, we have selected cluster config file. Go to src sideconf. Here is the file. I would like to explain this to you. It's little okay. So if you see, it says dt.operator.csv parser.property prop stands for property dot schema. So we are going to use CSV parser over here, which is going to convert your CSV input record to a POJO. So this needs to know how it needs to parse the record. So we say the separator will be a pipe. Our input records are separated by pipe, and we say like what is the field mapping. So we tell it like first record goes to the account number of object, and the type is going to be integer. The second field in our record is going to be the name in the object, and type is going to be string. And the third part of our record is going to be amount in POJO, and type is integer. So we need to set this string for parser as well as formatter, which is I have done over here. Then there are some attributes you see that we have set triple class on some of the ports. What it is, so these operators are connected to each other, and they do on the strings they do transfer data from one operator to another operator. So they need to set up a protocol like what is the object type or what is the exact object we are going to transfer. So this is a tuple class we should provide. So we have not done any compulsory mandatories. You can choose any object you want. For this example, I have created an object called POJO event. It's just a plain Java object with all getters and setters. And if you see, you can actually choose to have different objects on different streams. So as of now, I have used same object everywhere. But what you can do, you can choose different classes over here. I'll show you in the it will be more clear when we run the example, and I'll go into details. Just remember, like, this is the way we can configure this event, and if you are using some other object, please change this FQDN totally. Also remember, you can either add your object inside the application code, or you can have it in this class path. It just needs to be available. You don't have to always put it inside the like application code. And then this is the condition we configure from UI. You can put it in properties as it is. Okay, now we have seen, like, we have the code, we have the this thing configuration over here, and I have launched it, right? I said launch. Now let's go to monitor tab and look at it. So this is the application we just launched 3 minutes back. Okay. Now, as I said, we have one-to-one partitioning strategy. I had 2 Kafka partitions, so I have 2 Kafka input operators, one for each partition. The CSV parser I have. Then this is the unifier, which will unify the output from 2 Kafka input operators and give it to next operator, which is parser. Then we'll filter. Then we will format it back, and then we'll output. So this is how our DAG looks like. If you see a logical DAG, it's loading. It's taking some time. Just a minute. Actually, the logical DAG is going to be exactly similar to this. Okay, this is how it looks like. Filter, formatter, file output operator. This file output operator is actually HDFS file output. And let's look at physical view also. So this DAG is actually expanded into a complicated DAG, which is actually going to be deployed. So we have 2 Kafka input operator, we have unifier, we have parser, filter, formatter, and file output operator. Now I'm not sending any data, so that you see everywhere like all the records, like 0 records are processed everywhere, right? Now let's send some data over here. So I've created a file. I'll just quickly show you that, where we have like byte separated values, which like each record is byte separated value. It's a pretty big file. It will take some time to load. Okay, these are like records. This first is account ID, name, and the like balance he has in the account. Simple records. Okay. Now let's try to run. Yes, I'm going to feed this file to the Kafka console producer. So Kafka console producer actually comes with Kafka installation. If you have installed Kafka, go to bin directory. There you will find the script Kafka console producer. There you need to give these parameters, broker list, and everything as per your configuration, like as per your installation configuration, topic name and everything. And then either you can take data from your console, or I'm redirecting that into read my file. So I started putting in records, right? Now let's go to console and like UI. Okay, you see, it started processing records. You can see it has processed lakhs of records within few, I don't know, even not a second actually. Now let me try to add one more partition and show you how it dynamically scales. Now I'm going to add more partitions. I'm going to increase one partition, like from 2 to I'm making it 3. Okay, so I'll create a new thing. Okay. CB. Okay. Okay, now I'm going to run this command over here to change the partition count. I'm making it 3 now. And now let's look onto your UI. Okay. Okay, if you see, one more Kafka input operator has been added dynamically. I have not done anything. It has automatically picked it. And because the this operator I changed, all downstream operators are redeployed. Okay, now it depends on our script. Like okay, so if you see it, it's all dynamically handled. Now, if you have like observed this, we don't have a like transform operator over here. I have talked about having transform also, right? We purposefully skipped it because now I'm going to show you how to use this app template and add your transform operator very easily. So if you go to this repository and look out for the code, okay, I just missed that. Okay, filter src main Java this apps. This application Java is our main file where we actually define how our log, how our DAG is going to look like. What we need to do is we need to declare all the operators we are going to have. So I'm just going to kill this producer so it doesn't generate any more data. Okay, it's killed like it's done automatically. So I have four operators: Kafka input operator, a parser, a filter operator, a formatter, and file output. So you declare your operators like this. These classes are part of our open source malware repository. I have added to my dependencies in my POM, so I can directly use them as it is. I don't have to code for any of these operators. I just have to tell this application what all operators I'm going to use. So add it to this object called DAG, add all these operators and connect them the way you want. So I'm going to connect my Kafka input operator uh, operators output port to the filter operators sorry, to the CSV parsers input port. So output of Kafka goes to CSV parser input. Then output of CSV parser goes to filter operator input. Then output of filter operator goes to input of formatter, and output of formatter goes to file output where your data will be written to HDFS. Okay. Now you have this data, but you're not happy with this. You want to add something more. You want to transform. So here are some instructions to do like basic changes. If you want to do some really complex things, you can still do that. You can like use some complex operator like dedupe or enrichment, enrich or something. That you can figure out actually. This is a simple example of how you can do it. It says if you want to add this formatter, follow this thing. If you want to modify your pipeline to this, you need to add this operator called transform. Okay, and then after adding this line, you need to set this expression which says how do you want to transform the field. So here a simple transformation is done where object.name is up is like done a uppercase function on that. We just call uppercase to uppercase. That is we are transforming this field and this expression we are just setting to this operator. So we are telling this operator how to do your transformation and setting that to transform operator. Now we need to add the strings like modify our strings to have this operator. So it says like remove this string and add these new strings. So we are going to add this operator after filter operator. So once you do this modification, so I have actually done this in my repository already. So as per the instructions, I have added this transform operator over here. I have declared what kind of transformation I want to do using this Squashy Java expression. I just want to do uppercase. You can choose to do some complicated functions like you can do some math on the balance or you can do any other things. And then you set this expression on this transform operator and I have modified these strings. Now let's run this again and see how it actually works. So let's go back here. It has actually, see if you can see it has already processed so many records and already working. Now I'm going to run that another application. So I already actually uploaded that. So what you need to do when you actually modify any application, you need to build it again locally, and you come to this develop tab. You go to application packages, and you say upload package. When you say upload, you get some such dialog. You choose your application which you have built locally, which is normally called as a API.API file. You choose that, so that something like this will appear. This is like what I have modified. This application I have generated on now, and this is the tag, like updated tag. I have no formatter operator now. I'll just pause for a minute to see if you have any questions before I go ahead. Okay. So if you have any questions, please type in. We'll answer them as it. Okay, now let's try to launch this application. I have like modified this. Okay, this is application name. I'll say use this configuration file again. Again, we need to change these parameters, right? Use default properties. Temp ETL demo output of transform. Same expression, let's say, or you can choose something else here right now. Instead of 2000, you can say 20,000, you can say 40,000. Here I need to change the, okay, I'll copy this, setting this, and ETL demo. I already sent records to this. I don't need to send again. And I'm launching this application. Okay, it has launched. Let's go to this tab and see. Okay, the application is running now. Let's go to. So we already have records in our Kafka. It should immediately start processing them. See. So the Kafka input operator is active immediately and it has started reading the records. And now we have transform also. So it should do uppercasing and write it back to the HDFS. I'll just quickly show you the HDFS folder and data we have read. So what I'm going to do is okay. Okay. I'll just confirm what was the name of folder which I gave. 10 ETL demo. Okay. Oh, it's some other more. Okay. Okay. Looks like I'm actually not in my development environment, so maybe I'm not allowed to access it from now. No. Okay. Don't worry. Like for sure the files have got created because it doesn't show any errors over here. It is showing that it has processed. If you go to Kafka output operator, this it is showing that it is processing records and it must have written to the file by now. Okay. Uh, so having said this, like we do have all these ready to use solutions which you can actually use it as it is, or you can modify it the way you want. There are basic instructions to do some modifications, but you can do many complex things. You can just look at our Mallar library. There are many more complex operators available. We are going to cover many of those operators, how to use them in coming series. We also have one more example repository where we do cover examples and we do show like how do we use each of these operators. So you can have a look at that also. So I'll say please feel free to go try it out, like try out these templates on your own, modify it the way you want, and you can use it. If you have any questions, actually do post to us on this. We have the question. Okay, I'll just pause for a minute if you have a question.
Okay, so thanks Priyanka for the wonderful session. We have a couple of questions. Well, the first is what happens to my application when the Kafka operator is the node where the Kafka operator is running is down. Okay, yeah, actually I should have covered that. So what happens? Let's say your node is down. The operator will be killed obviously because it was deployed on that operator. So it's like we do use YARN for scheduling. So
we do detect that there is something wrong with this operator. It is not sending us heartbeats. So we do declare this operator as killed. And as I mentioned in first slide, we do maintain state of this application. So even if the operator is killed, we know the state of that application at some point of time. We do keep saving the state at some time intervals. So what we do reschedule running of this application on some other node. I can actually quickly show you that. So let's say in this, if I just kill one operator, you can forcefully kill it, it will actually get redeployed on some other machine and it will start processing again. Like let's say my this Kafka input is on cluster container 5. I'll go to container 5 and I'm going to kill it. Okay, if you see, just monitor this container 5 is killed. It is going to be redeployed on another container, node 10, which is on different machines, maybe node 35, and it starts working again. So you don't lose anything. It will go back in to some known state, and it will start processing again. Your data won't be lost. So all that fault tolerant is handled by a platform by default. You don't have to do anything on your own to handle such situations. Is there any other question?
Yeah, so the other question is how do I actually make my operator partition at runtime?
Partition at runtime.
Dynamically.
So as I mentioned, we have two strategies. Either there is one-to-one or there is one-to-many. If you want to, like, if let's say your load is very high, you think your operator can't handle it and you want to have more partitions. What you can do, you can actually add more partitions in your Kafka topic, so that automatically there will be more partitions on application side, and you can distribute your load among these partitions. So I think it will serve your purpose. I hope that answers your question. Okay.
Okay, so thank you, Priyanka, for the session. So there are some questions so there are some questions for the links to the webinar, recorded webinar, and other things. So we'll answer them on the panel, and you can find the links to the webinar on the YouTube channel of DataTorrent. And any slides you want, you can look it up on the slide share. Even there's a DataTorrent account. You can look it up there. You can find it. So if there are any questions, just type them onto the questions tab. We'll answer them as they come in. And thank you for your time.
Yeah, and post this session, if you have any more questions, you can actually join our discussion forums. We have users forum to answer users query or developers forum. So you can just put your technical or use case questions. We will be happy to answer them. And this YouTube channel, which Bhupesh mentioned, has almost all sessions which are delivered by DataTorrent till now. So just find your relevant session and it could help you. And yeah, the next slide is like we are hiring. So if you're interested, just send your resume to jobs@datatorrent.com. And if you have any questions, we'll wait here for some more time. Just type in your questions and we'll be happy to answer.